So at the end of this chapter, we'll have three additional examples. Okay, this is the first one. Okay, here shows a thin plastic rod of length L. This one thin plastic rod length L equals 13.5. 什么？ what is that? What is that? Or maybe just a typo. I think it's just a typo. Okay. This one, L should be 13.5 cm. Just ignore the EX. And uniform charge 43.6 femtocoulomb. In terms of distance D, this is D. Find the expression for the electropotential at P1. At P1. This is small d. This is small d. Capital D will be the next. Will be question B, something like that. Yeah. So for P for this one, dV will be 4 pi epsilon 0 dq over d plus x. So actually, this is the x-axis. So the rod is from 0 to capital L, which will be the lower and upper bound of the integral. And actually, the distance between every small fraction, this may be x, this may be the dq, and x-axis will be x, something like this. So the distance between P1 and this small charge will be small d plus x. Okay? Okay? Clear? This is V. This is V. So suppose the density will be lambda. The line charge density will be lambda. So dq will become lambda dx. So we substitute this here. dx lambda d plus x. And so we write as an integral. The total voltage potential will be integration of dV, which will be 4 pi epsilon 0 lambda. Because all of them are constant, so the only stuff in the integral will be like this, and the lower and upper limit will be 0 to L. So this one is very simple, just log of so this one is just log d plus x, and then we substitute L0. So it will be something like log d plus L over d. Okay. So you substitute all the numbers in it. Actually, we can make a small substitution. We can further multiply L and L because we don't know the lambda exactly. We only know the total charge is this one. So we only know that lambda L equals 43.6 femtocoulomb. In this case, we just multiply L on both denominator and the numerator, so that this one will be the total charge. So this one will be 43.6 femto. So make sure you really calculate something like femto and nano, something like that. Don't keep n here and then you just ignore it and just calculate the number. Some of you doing like this. Make sure you care about the prefix. L is 0.13, 0.135 times 8.99 times 10 to 9, and actually this one will be log d. What is d? Oh, d is not given. D is not given. So actually we just keep the expression like d is not given. We just calculate a closed form. Actually, this will be something like 1 plus L over d for this one. So actually, it will something like 0.135 over d. So it will be something like 2.9 millivolt log 1 plus 0.135 meter over d. Any question regarding to this? 哦，因为它有单位，其实这个是个单位，log 是没有单位的，整个放在后面也没有的，但是它就表示说这个没有单位，然后里面的东西也没有单位，那这个就要有单位，表示说这个单位跟这个单位是一样的。 Any questions? Okay, next substitute value x for d and find the expression for the magnitude of the component Ex of the electric field P1. So actually, so we can write it like this. V equals V0 1 plus L over D L over X. So you can written like this. So that's why I write MV here, because you can regard it as a voltage at 0 point, and right at this point when x is equal to 0. And for this case, x-axis is pointing that way. For this case, the x-axis is pointing this way. This is 0. This is actually the x-axis. Okay? Because when we count d here is from here to here. And it asks you to substitute variable x for d. So for this case, x should be counted from here to the left side.那反过来了。So V0 should be infinite far away, should be this point. Okay, when x is tends to infinity, then V equals V0. Yeah, so it should be something like that. Yeah, you're right.我写漏了吗？OK， 对 ，yes， log. So maybe I just rewrite it. Oh yeah. Not really. Oh, this would be something strange. Log 1 plus L over X. Not really. Not really. So this is not correct. Because when x tends to infinity, this one is 1 and log 1 will be 0. So when far away, the voltage will be 0, which makes sense because this rod shouldn't influence infinite far away. So V0 means 1 plus L over X equals to E, which would be a strange distance. Something like that. So E minus 1, so it would be something like X equals to L over E minus 1. Then V equals V0. But this is irrelevant to this question. But as long as we can write it like this, we can find the E view. We can find the E view in this axis, in the x-axis. So Ex can be written as minus dv dx. So we just take the derivative, something like this, 1 L over x, and chain rule, we take the derivative of this one, so it will become L over minus x squared. Yeah, that's correct. So it will become minus v0, L plus x, something like this. This is some algebraic, so I think this wouldn't be difficult. And so we substitute all the stuff in. So this is minus 2.9 mini times 0.135, and actually this is 0.135 plus x times x. So it will be something like minus 3.92 times 10 to minus 4 voltage meter, and actually over 0.135, this is meter, plus x. So this is meter, so meter over meter square, so it will become voltage over meter, which is the SI unit for the electric field. Direction relative to positive. What is the direction? Okay, for question C, it asks you what is the direction of Ex relative to the positive direction of the x-axis. Okay. Relative to the positive originally. This. So actually, because this is negative, this is positive, so this overall term is negative. So for C, because Ex is negative, so actually, because the x-axis is pointing to the left in this situation, so so Ex is pointing to the right, But actually, when in quiz or exam, if you define your own coordination, make sure you draw it on the paper. usually the x-axis should be pointing to the right and y-axis pointing to the top. So if you make it your own way, so you must let me know. Otherwise, I assume you use the original coordinate system. And actually for D and E, a thin plastic rod of length, actually the same rod. And what is the value EX at P1? Actually, okay. So we just substitute X equals D equals 6.2 centimeter into the pelvis equation we derive. Actually this one. So nothing special. EX will be something like minus what is the value of EX? Value of EX. Okay, actually we can just calculate the magnitude of it. So it will be something like 3.92 times 10 to minus 4.135 plus 0.0062. So it's nothing but 0.0321 Newton per Coulomb. Or you can write volt per meter. So for the symmetry, determine EY at P1. EY, actually, for symmetric, actually EY will be will be 0 for sure. And for the question, have A, B, C, D, E. So you should mark A, B, C, D, E on your question. I don't want to find your answer for 10 lines and then I just pick up your answer. Any questions? Any questions? BC 的 EX 不是写成 ED 哦，没有，他就叫你把 D 换成 X 啊，把那个当成 X 走。Okay, so for this one, a plastic wad has been bent into a circle of radius r equals 8.2 centimeter. It has a charge Q1 uniformly distributed along 1/4 of the circumference in a charge Q2 uniform distributed along the rest of the circumferences. So Q1 is distributed here, and Q2 is distributed for the yellow part. With V equals 0 at the infinity, what is the electric potential at the center Z of the circle? So actually, this one is quite simple. So V will be something like, maybe we can write VC. So it will be something like 4 pi epsilon 0, the standard step, and Q1 over R plus minus 6Q1 over R. So it's so simple for this. Because Q1 is distributed here, actually it tells you it is uniformly distributed, but no matter how it distribute, then the distance between them are also the same, but R, because it's a circle. So actually the first term will be Q1 over R. And the second term, Q2, Q2 is minus 6Q1 distributed here. So also the distance between Q2 and C is also capital R. So the second term, minus 6Q1 over R. And it will be minus 5Q1 over epsilon 0 R. And we substitute all the stuff. 5 times 1 times 10 to minus 12. So it is minus 2.3 volts. Actually, minus 5 here. So any questions?
这个数据本来应该按词分布算，但是其实只要算标量，就是直接用整个屏幕之后，数据带进去了。
是，你喜欢积分的话也可以。
所以它就没有什么等同于一个整体吧？这其实还是算子的那种想法。
是原则上你也可以说 Q1， 然后你要弄一个 density， 然后用积分，但是那个积分又是一样的东西。Yeah, actually you can write it as integral form if you really like integral. So for question B, what's the difference? Okay. Actually, the shape is the same, and actually it asks you the potential at P rather than C. What is the electric potential at P at point P on the central axis? Distance D equals 6.71 centimeter. So actually, this is similar. Ouch. Whoa. 什么情况？擦不掉。OK。Okay, this is R. This is R. Feeling got drunk. Okay, this is something like this. R would be R squared plus D squared. So mm, 6 point, ouch. So you may wonder why I usually write 0.0082 and 0.007671 for these two in meters. But actually, if you just keep it in mind, for this step, I just calculate R, which is all the way, I use the cm, so it turns out will be cm also. But if you mix with other stuff, so try to make it less confused to you and me. So we always convert the unit to be meter rather than centimeters. But for this case, I make it very clear. This is centimeter, centimeter. So the answer is also centimeter. Then you will make mistakes for this. And actually, VP is also minus 5 Q1 4 pi epsilon 0 small r in this case. Actually, the same derivation with compared with the previous case. The only difference is the difference is something like this rather than this. So you plug in all the values and the answer will be 1.2 times 10 to minus 12. Well, no space. Times 8.99 times 10 to 9. And at the bottom, R is 10.6 cm. So it will be 0.106, 0.106. So this one should be on the top. And the answer will be minus 1.78 volt. Of course, smaller than the previous one because the distance is farther. 有什么问题吗？我说比较远了，所以比较小了。有什么好惊讶的？Any questions? Any questions? Okay, we can finish the third one, and then we can finish. The third one is very simple, actually. Plastic disc of radius r equals to 64 centimeter. On one side with the uniform surface. The density is like this. Actually, originally it's a full plastic disc. And then 3 quadrants of the disc are removed. So for this charge density, no problem, because it's just fill all the charge on the whole disc and then it removed the 3 quadrant. So only 1 quadrant is left. And with V equals 0 at infinity, what is the potential due to the remaining quadrant of the P, at point P, or at this point, which is on the central axis of the D equals 25.9 centimeter from the original center. So actually, for the whole disk, just without this 1/4, as we derive. So actually, because it is only 1/4 of the disk is left, so we multiply 1/4 to here, because this one and this one, maybe I use the laser pointer. This one and this one will be symmetric for the scalar, because the direction is not important. So this one will generate the voltage here. This 1/4 also generate the same voltage here, and so as this 1/4 and this 1/4. So if it's only 1/4 quadrant is left, so we just multiply 1/4 to the original expression, and we substitute all the stuff in. So it is just 1/4 times 7.73 times 10 to minus 15 over 2 times 8.85 times 10 to minus 12. Z is capital D. Capital D 0.259 square plus 0.64 square. .64 square minus Z is 0.259. .259. Hmm? 0.64. So the answer is 4.71 times 10 to minus 5 volts. That's it.